just for everyone that's not aware, hopefully everyone's seen the blue screen. And we're going to talk a little bit about what we do at PPS with regards to hand activity level measurement and assessment. So this is a talk that's been slightly butchered from what we did recently at the Applied Ergonomics Conference in 2026. And I'll talk a little bit about who we are, what we do. So ultimately, PPS is an American company. We've got our CEO on the call here with us. It was founded ultimately after research in the Harvard laboratory, looking at how to improve the sensitivity and repeatability of thin film pressure sensors. And obviously that was around robotic applications. But as the company's grown from those early days where there was DARPA grants, understanding how surgeons used these sensors to grasp and measure the grasp forces of their tools, it's been continued to evolve around human body comfort and fit assessment. And we do a lot of work in both the hands and the head space. So there's that kind of fundamental understanding in the company since its birth, and we're seeing that kind of coming full round and full circle with recent the growth in robotics and AI applications. But people really are always interested in measuring pressure and force, and I'll talk a little bit about that today, but also how we measure pressure and force distribution over an area. It's all great getting one value, but if you want to understand how people interact with objects, whether they're grasping it or piercing it or holding it, having one value for the whole hand can be quite limiting. It can average the data and you can miss key metrics. So we're trying to understand that distribution of pressure and force over an area. But our technology is capacitive. So it's two metal plates separated by an insulating material. And that insulating material you can think of as a little bit like a spring. And as you press down with your applied pressure or force, the distance between the two plates decreases. And we measure that change in capacitance. And through our calibration, we convert that to an inferred value of pressure or force. What this means is that stack up. If we design that spring correctly, we can optimize the mechanical sensitivity for a given application, and we can really ensure we're in the elastic region and we get good repeatability over time. So sensitivity and repeatability are our key metrics. In terms of this webinar and looking at fine dexterous manipulation, in the early days of the company, there was the first and it was an analog output times and system, and we'll talk about today on the call is our FingerTPS system. Talk about how to use and success using the finger to put them on later on the call. They are worn on a finger, and for people to see, they can slide on, and you get your single element sensor on each finger. And we've got them to cover the palms and other regions too. And they integrate into a small electronics module and allow us to measure force per element. We've also got our TactileGlove, which has got 65 elements in a fully wearable glove. Again, fully wireless, but allows you to capture that full distribution over that area. So what does the FingerTPS give us? Well, I've just put a couple of example videos in here, and everyone's going to give us more of an applied description of the work she does, but it allows you to understand these fingertip and other key region interactions. So I like this video on one specific regard, and I've the key points coming up. But as you press Starbucks coffee mug, you can actually we've got the lids popping at around sort of just breaching 15 newtons. And you can start to understand how simple tasks can be measured and mapped for looking at improving products, improving worker safety, and also workers' efficiency. So we've got various different examples of that. Here's one with performing some very, very fine manipulation on a straw, looking at how do you grasp a compressible paper straw. We've got a lot of these paper straws in the UK and the EU right now, and they collapse pretty quickly. And the idea here was trying to understand how different straws behaved. Again, you can see quite clearly the different forces and that interaction, whether you're wiping or grasping these very, very fine objects. That's our FingerTPS product line. But what I'm going to talk about is our TactileGlove, which also can be used for that array-based measurement, understanding the pressures across that full hand. Simple examples here, if you want to understand how different power tools are designed or improving those handles, understanding how an operator uses those, we can get both the distribution of the pressure and the actual individual elements and the peak forces. So we've done things in ergonomics of tools. Sports is an interesting one, understanding how different performance athletes actually can use their craft and their skill to improve their ultimate performance, and how we can then use that as a training tool for other future stars. But also, again, just that fine manipulation and understanding how even on small stems of wine glasses, we can actually map that. Now, if we take all that data, what do we get? Well, ultimately, we go away from the single element manometer and we go into the actual full glove that gives us that distribution over the hand. So we're going from the dynamometer to the full hand information set. Now, well, that's good from a scientific level, but I suppose what does that actually give us usefully? Well, if we look at the traditional NIOSH standards, we start to look at hand activity level, and you can quantify two key things. There's the frequency and the duty cycle of a particular task, and then there's that normalized peak force relative to an average worker strength. And then you can start to bind these into sort of three discrete categories. The traffic light system. So green, everything is good. There's an acceptable level of risk. Orange, things need to be prepared and considered, and then risk assessed much more closely. And then red, there's a significant high risk, and immediate solutions are required. Now, a lot of that was done previously quite, using videos, trained operators trying to be very subjective, but clearly it wasn't very quantitative. So what the idea is, that could we actually start to bin this a little bit more with actual quantifiable measured data? And we could use the rating scales that they've got, and could we use the TactileGlove and our FingerTPS to work with these existing standards, work with these existing protocols, and provide a digital tool for the sector? So the good news is the answer is yes, and I'm going to give a couple of quick examples of this before I hand over to Evelyn. So what does that allow us to do? Well, if we've got a digital tool, the first thing is it's very quantifiable. It's calibrated, it's accurate, it allows people to get a really definite record, a finite record of what was happening for a particular task, process, or person. And then we can effectively instrument the hand and understand those, and then capture that to improve the process, the product, or the safety of the application. So a couple of quick examples. If we took our standard TactileGlove, it's calibrated in pressure. Our standard FingerTPS system uses a force gauge for calibration, but our TactileGlove, because the array elements, we calibrate in pressure. We can convert to force magnitude effectively with the element sizes. So we've got elements as small as 5 by 6 millimeters on the fingertips of the glove. And then we can look at that estimate of total force magnitude by knowing our pressure and our area. And then we can also look at that time-based aspect. So the question I would ask everyone is, what's better, a high peak pressure for a short duration or a lower peak pressure for a longer duration? And that's a hypothetical question, but it's one that's worth considering, and one we covered in another webinar. But if we were just to look at sawing a block of wood, and we've got manual tools, we've got power tools, and we've got different reciprocating or oscillating tools, well, which one's the best? Now, depending if you're a purist and you're a carpenter, the manual tools I get people would like, but a lot of people like to go to power tools to make things quicker and more efficient. So what does the TactileGlove give us? And this video is just going to go and show this really dynamically. So we get that pressure map across the hand that shows the distribution. We've got the peak pressures at the bottom, and we can quantify all the different parameters in real time at roughly 50 hertz. What's really interesting is, if we look at those power tools, the power tool and the reciprocating saw in particular was the quickest, but it had the highest peak pressures, over 6 times greater than a manual saw. So what was really interesting, if you start to look at effort, because of the time, the reciprocating saw was the lowest effort, which is measured in that area under the curve of pressure and time. But the manual saw was actually one of the pad saw in particular was the lowest pressure. So if we just looked at peak pressure and we didn't take account of time, we would say that reciprocating saw is the worst. But as we know, that is used routinely. But what we can then start to look at is under which bounds are these actually operating. And you can start to see that actually, if you're not careful and you don't have appropriate risk assessments, you can start to get very much into the red area of high risk with any of these manual or power tools at different scales of the hand activity level and different normalized peak forces. But what it's showing here is for workers in these type of environments using these tools day in, day out, there is a risk that needs to be managed and controlled. My final example is that, well, if we were going to use this to spread glue, so we've got different glue arrangements where we've got a credit card shaped handle, we add some foam to it to make the area larger, and then we add lots of foam to it to make it a little bit softer. Which one is better for the operator spreading glue in an aerospace aviation industry? And what we can see here is, again, the peak pressures actually with the simple sort of standard spatula are actually the highest there, the peak at about 28 psi there. And the pressures generally fall down as you add more surface area to the tool. So we've got the bigger tool here, and you can see the pressures are generally getting lower. And then when we add more foam, we've got more surface area, we've got more contact area, and we can see the pressures reduce even further here. So you can see this one here. I need to talk a little bit slower, and the pressures drop off. But what's really interesting is that when you actually measure that whole thing out, the large foam handle actually takes more time to spread the same amount of glue. And the analogy here is a bit like bike suspension. When they're racing their bicycles, a road cyclist doesn't have lots of suspension, losing energy, damping energy. It's definitely comfier if you have that, but you effectively more of a rigid ride. So it's really important to understand where they all sit within that hand activity level. And with our tools and with our software, you're able to then plot exactly where on the hand activity level map these sit, and then take appropriate references. Products, and then assess safety so that we can then start to make improvements both to the product, the processes, and and how the people undertake those, so that we optimally have a more efficient and safe working environment. So what do we have on the horizon? We embed inertial measurement units into our glove. And what that allows us to do is really exciting. We can now start in the same environment. And what that allows you to do is clearly start to look at much more granularity, what's happening in a particular application, understand where the forces are being applied and what directions that are being applied to. So it starts to really become the holy grail in that regard. What I'm going to do is we're not going to ask any questions right now, but I'm going to hand now over to Evelyn, and she's going to give her introduction to Edwards Life Sciences and what they've been doing in terms of improving the ergonomics in the very exciting medical space. Over to you, Evelyn.
Yes, thanks, Charles, for the introduction. Can everyone hear me okay and see my screen?
Yep.
Wonderful. Great. Well, let me introduce myself before I get started. So my name is Evelyn Boulay. I work at Edwards Life Sciences. So Edwards Life Sciences make medical devices, and I'll talk a bit more in details about what that is. But I am Director of Environmental Health and Safety, but more specifically, I'm subject matter expert for ergonomics or ergonomic within manufacturing. Not that I don't like the office, but it's much more fun, challenging, and riskier on the manufacturing side. Basically, what I do is I identify, evaluate, prioritize, and implement action for manufacturing related ergonomic risk. And we're trying to improve our design for manufacturing to make sure that our processes are better for employees, but also easier to make and get our product out of the door. Just kind of a little bit of my background. I have mastery in biomechanics and ergonomic. and I've been doing ergonomics within manufacturing for a few years now, within medical devices, the food industry, and aerospace. So I went from the biggest part in aerospace to the smallest, tiniest part in medical devices. Just kind of give you an idea of our journey for ergonomics at Edwards, and also how I got to work with PPS and the equipment of the company. So I was hired at Edwards in 2018 just because we had a large amount of ergonomic related injuries. I guess you can call this job stabilities, but that's how I got a job at Edwards. And we started making changes right away. We created our own ergonomic risk assessment tool internally, taking a little bit of a Reba ruler, things from Europe, things from Asia, things from North America, and things that were also fitting with the job task that we have within Edwards. And then one of the big things that was missing when I started was that we could not quantify basically what our employees were feeling. So that's how we started with FingerTPS, basically, because we needed to have something that was very subtle, something that was very easy to put under our employee's glove, something that was just not making the task more difficult, but was kind of incorporated within our people's just regular daily task. And then you could see over the years, we've done a few more improvement within our workstation. We started working with R&D to basically kind of attack the problem at the source. Hired more people, which is always a plus. So I have a team now instead of being a team of one. And then started finally having some products that were lower risk for our employees to make, which is a big, big win. And also started having a decrease in injuries. You can see in 2024, we actually developed our own AI ergonomic risk assessment, which I'm going to talk a bit more in a second. And we started finally having official metrics for all of our products, which was a big win. And obviously, FingerTPS was a big help to get that quantitative data for our business partners. And then we recently, last year, opened our official lab. I don't know if there's anyone on the call that's from universities. It's nothing like a university lab or anything fancy like this. It's probably just an extra conference room, but we're very excited to finally have more consistent, location and things to do testing within our four walls. And then just recently this year, we actually were at the Ergo Cup as well, like Ergo conference like Charles was, and we won an Ergo Cup, an award for our Ergo risk assessment, and that is also taking into account the data from the FingerTPS. So very exciting. We've had quite the journey, and then obviously within all that, our injuries for our employees have been decreasing significantly, and that's been always our number one priority. So let me give you more information about how we do our assessment and how we're using the FingerTPS. Our mission internally is really to design product that are best for, Edwards is a big patient company. Our patient is first, always. Also for a physician, so it's easy for them to implant our product within patients. But really, my number one goal within the company is to make it easier for our people. How do we do this? We need to make sure that our employees are safely manufacturing our products. So you can see on the picture, that's how our employees are working, mostly on their microscope, tiny meticulous part. Our valves are that tiny. All the stitches needs to be done on their microscope. A millimeter difference can make a big change in a product being approved or rejected. So obviously it's quite meticulous. And it's also very hard to make, and you need to be quite precise. Our goal is to have design all of our product basically with no high risk to make sure our population is good to make those. But how do we make this happen, right? This is the big question that I get all the time. And I say this over and over and over. Data is the most powerful thing that you can have. Yes, obviously you have feedback from employees, right? Feedback of users, of people that are sewing our products. And it could be like, oh, that one is really hard. That one is really giving me discomfort. But then if I want to go to a VP or to management to be like, hey, I want to make changes. I want to make a change with this product. This is way too difficult to make. We're never going to make this, at a higher rate, higher volume without injuring people. I need to have facts. I need to have data, and I need to have data that is consistent and that people can count on and really kind of make a difference. That's why in our ergo risk assessment, we implemented basically a lot of data accuracy, consistency, things that a process that's fast and simple and also accessible, that requires minimal material, but really improve our risk reduction for our best assets or employees. So that's how we do our testing. So I have a few video here that you can see. So we put the FingerTPS on, the employees first calibrate, and then they're able to put their glove, their regular glove, as they usually do, which is super helpful because it's just their regular duty and not extra bulky or very, thick. They're able to do their regular job. And then we collect the data with our risk assessment. Which is really nice because we sync both of those together with the help of PPS and internal at Edwards Life Sciences. So I could see all my frequency of movement. I can see if posture are being maintained for how long. And then at the same time that those frequency of movement are happening, I have the FingerTPS that are recording the force. And then every time that this is happening, they can just kind of be counter reference and just looking at the data of how often it's happening, but also how often do we have a high force, when we have peaks or things like that. So very, very helpful data for us to collect. And you can see here within the lab, we can get all the data when the employee is at the microscope. Everything is being collected, and we can be here, like I said, synchronize the frequency and the force data and the posture, so all at once within one report. So once we have the data, right, we share with our engineering team, which are the ones making the changes in the design. It's very fast. We usually get the report right away once after we record the task. And we have live collaboration with our engineers, which is super helpful. It's really more kind of a discussion. We have the feedback from the employees, which is our user. So we can all brainstorm together about how we can lower those risks, lower those high forces, and kind of what is creating it. And how we can just make an improvement going forward. And then we can, after that, make data-driven decision, which is very, very important. And within the business, I'm sure you guys know everything. I don't want to say everything is about money, but it needs to make sense financially. So data is super important for us to prove what makes sense financially rather than what doesn't, and how we can just make sure our employees are going to remain healthy without discomfort as they're doing their job. So then what do we do with this data, right? It travels all over the company, I'm not going to lie. It's being shown in a lot of product reviews, supply chain. So when we review the product as it's going through the different milestones internally, in any transfer meeting. So if this product is going from one side to the other, when we do concept selection with research and development, when we do risk reduction meeting, when we do any senior VP meeting or operation meeting, our goals review, launch of our specific product, again, R&D review, product new generation. So this data is being used all over the company. That's why it's very important for us to have, first of all, quantitative data, but also very valid and consistent data that we can compare apple to apple, a product, for example, of an initial generation to a new generation, if we're making changes for our patient internally for their heart, to make sure that its product is also being easier to manufacture or to assemble for our people, so they don't have higher risk when they do assembly of the product. And obviously our ultimate goal is always to remove or reduce completely our risk. And then our ergo risk assessment and now our early effort with R&D has been really promising. And well, I mean, we're not perfect. We're still making product with our hands, right? We don't have robots all over the place. Obviously, that would be a reduce risk forever. But it's something that we make. The earlier we can get and the more data we could get, the more changes we can make actually, and make a big difference for our employee down the line when we're going to be high volume and when we're going to have thousands of employees making those products. And then so it's big changes for our engineers and our product team. You could see here, I put tons of different kind of feedback of engineers that I work with or that my team work on a daily basis. For them, it's a game changer because I could be so specific on what is high risk and what is not, and that could give them a clear line of what they need to change within the product. So very helpful for them, but also our feedback from the employees. I've been also a game changer. I've had a lot of employees coming to me in tears, almost, and be like, "Hey, you're finally the person who understand like what we were feeling." And I keep telling them, my job personally is to just put numbers on the feeling that they have as they're doing their job on a routine basis. So if I'm able to image this with data or with the story of how it looks now versus how it was before, how it could be in the future, I guess our job is done for our people. Yeah, I tried to go as fast as possible, Charles. But if there are any question or any parallel that you want to make with this, yeah, I'm
Okay,
ready.
yeah, no, thank you for that, Evelyn. Yeah, so it's obviously yeah, trying to improve process and the workers' environment is key, and hopefully that's come across. So now's the time for people to put questions in the chat box, and if the whole incentive to do that is obviously hopefully you've got lots of questions, but and it also stops me asking mundane awkward questions. So hopefully people can put things in. Obviously, really just kicking things off there, Evelyn, is, what has been the single biggest difference by digitizing or capturing that force information in your process? What's the single biggest lever it's pulled?
I I think the big difference for us is I've been in these meetings. You have we're a business, like it's the product needs to get out next month. It's like quite like the timelines are aggressive, everyone is working towards that, there's a lot of money. And then I came in a meeting and I'm just like, guys, this is terrible for employees, and everyone looks at me and is like, how terrible? And I'm like, it is terrible, but terrible is a big word, right? So now to be able, like, is it, like you were saying earlier, are we talking about like a just a moderate risk, or are we talking about a very high extreme risk? To be able to quantify this and to put, so we have an internal scale of risk, um, similar to the NIOSH one, for them to see like, oh, is this a yellow, or are we dark red, black, right? And then I think once I get the data, and then you see like what's the force related to it, how often it's happening, and not only just within the task, but if you put that like your hourly rate, your weekly rate, your monthly rate, and people are just like, oh yeah, that is a lot. And I'm like, yeah, that's what I tried to say. But the more data, I think people understand better, and in every person understand in a different way. So I try to put either like just the raw data and the hourly rate and the estimated monthly rate plus overtime plus this plus that, right? And then people start seeing the picture and they're like, yeah, I don't think I would like to take their place. Or I
Yes.
don't, and I also ask that often, like, would you like your mom to take the place of our employees or a family member? And they're like, no, probably not. I was like, well, that should be your first red flag right there. So usually it's a good conversation starter, and also an eye opening for people that are not directly dealing with the product or the employees.
Okay, so you've seen definitely a shift in when you've got the data, people believe it a lot more than just subjective.
Yes,
Yeah.
correct.
Okay. Well,
Or
we've
just
got
taking my words for it,
well, yeah. No, I'm
versus,
a trusting person, but we've got two questions now. So the first
yep.
question is, the level of injury improvement is very impressive. What were the top three factors that contributed to the improvement?
So first, I think we knew already where the risks were, um, and we had a lot of good ideas of improvement to to make sure that those injuries, risk would reduce. But we didn't necessarily have the bandwidth, funding, or engineer help or anything to implement those changes. The data that proved that we could do like what's current saturation versus future, was really key for us. For example, the new workstations that we implemented to get the funding for this, to explain like if we don't change that risk, here's how worse it can get, right? So we were able to secure funding internally for this, which was a big win. And we did a few tools changes and improvement that was really a big game changers for injury reduction, and that we were able to prove again our point and to get help from engineers to make the changes, because you need to change your standard operation procedure. You sometimes need to resubmit to the federal, legal and all other uh, association that our product are, approved within. So when you need to resubmit, I'm not a lawyer, so I can resubmit our products. So to get the help to do that and to make those changes come to life was probably the biggest help. Again, data is just the most powerful thing that I can use personally to make things happen that we already knew we wanted to make happen.
Yep. Okay. Perfect. And then Mike's asked a question. Is this, I suppose this is probably more directed to me. So is this technology only applicable for research applications such as you're presenting now, or is it suitable for mass production? So, Mike, I think that's obviously a very good question. Obviously, the tool historically has been used in a lot of R&D applications. That's where its birthplace was in, and someone here. So and that's obviously where a lot of the work has been done. Evelyn has certainly taken it to the next level and is using it for multiple hours across multiple people daily. But depending on your application and your environment, what you're trying to do. So, for example, if you're trying to lift heavy automotive batteries, that's not a tool for it. We have got other tools, and we can productize and industrialize it as required for an application. So what I would suggest is we could have a conversation offline around that, on what would be needed for your particular application and the times and the durations required. I'll
If
let
I could
Evelyn
add
come
to
in here.
that, Mike, for us, because we are in a clean room environment for our commercial production, I cannot bring the sensors in, because that would mean I would need to dunk them in acetone and alcohol to clean them, which obviously Charles could tell you it's not recommended to do that with your sensors. So we do our testing in either a training environment or in the lab, which we're recreating the commercial environment as much as possible. Is just not the actual commercial environment, but it's pretty much, I'd say 95% the same. And we're testing people from the commercial environment as well. So we're creating the reality as much as possible, just not in the commercial environment for just logistic purposes.
Excellent. Okay. Thank you for that. So we got any last questions from anyone? This is the last chance. But obviously, yeah, so we've obviously got a good comment there. It was great to see how our sensors are used to make a difference. And Jace, thanking you, Evelyn, and the wider team. And again,
They're
congratulations on
definitely
your Ergo Cup.
used. Thank you. They are used to make a difference, and if I can add too, in the lab we have our ergonomic wall of fame, because I think the employees were a bit not scared, but you add more just technology on them. They're asking, what are we doing with this? What's going on? I think there was a little bit of an element of fear at first. And now they know that they're kind of like on the Hollywood Wall of Fame. We take their picture with the sensors every time we test a new product, because they are helping us. They're trailblazer, right? They're helping us to make a difference. So they're not afraid of the technology anymore. They're embracing it, and they're now always asking, like, what's going to be the next testing? Can I be part of it? I want to know what the tests are about, those sensors. So it's been a great journey, and now it's really part of our routine, that I would say.
Fantastic. Yeah, that's a great thing to hear and get that. And hopefully, we'll have more people on the Hall of Fame soon, and that can grow. So,
Almost
so
3 people on the Hall of Fame, so it's getting bigger. It's great.
Okay. Um, so yeah, I see Mike's response. I would like to know so can if the sensor can differentiate between yes, you could do that, and what I'll do suggest, Mike, is yeah, we can have a chat offline and go into that application area in a little bit more detail. Oh, well, thank you all for joining, and we go over that initial wee hiccup. And again, I would like to thank Evelyn who's made this webinar, and you know, really show the difference innovative technology can do out in the field, providing quantifiable data. So thank you very much, Evelyn, from everyone, from me and everyone at PPS. That's much appreciated, and thank you everyone also for joining and taking part today. Okay,
Thank you. Have a
thanks,
great
folks.
day.